Okay, so we're on explore number 6 of Chemistry 1.1. The essential question, what are some examples that show how thermal energy is transferred by means of conduction, convection, and radiation? So we need some examples of conduction, convection, and radiation, right? These are the ways that thermal energy is transferred. So take a moment if you have not yet and write down what you know. Okay, make sure you write your essential question here and then write down what you know, or give me some examples. Okay, so let's jump into our notes. Roman numeral 1, there are 3 methods of heat transfer. You can see we're looking right here at your text. Those are conduction, convection, and radiation. You can, of course, read that. We want you to read it and watch the videos, etc. Conduction. Objects must be in thermal contact. You touch something like a tabletop or a glass window or whatever, and you can feel the object is either hot or it's cold. That's because you have made thermal contact. You are touching the object and heat is flowing into your body or it is leaving your body. Now, the interesting thing here with conduction, particles themselves don't move. What do you mean by particles? Well, those are atoms or molecules. They themselves, they don't travel per se. They vibrate as they absorb the thermal energy. They become excited. They start to vibrate vigorously, and they collide with each other. And as they collide with their neighbor, they pass on energy to the molecule or atom next to it. And then that particle vibrates and passes energy to the next particle over. And on, it repeats this process, what we would call a chain reaction of collisions. And that's how the thermal energy travels, traveling from areas of high temperature to areas of low temperature. So in this case, with our heat here on the left, heating up the bar, it gets hot over here. The particles, they start to vibrate, and that energy is transferred down the metal bar. All right, the next example we have here is convection. In convection, particles actually do move. This is seen with substances that behave like a fluid. They have fluid characteristics. Of course, liquids, anything in a liquid stage has fluid, behaves like a fluid. Gases also behave like fluids. They have fluid characteristics. Think about dry ice. When you open up a container of dry ice on Halloween, that cold air, that mist just kind of follows the tabletop and falls to the ground as if it were spilling, right? Just like water. All right, so what's actually going on? In our example here, we can see we have a heat source that is heating up the air particles. They start to move around, and in moving around, they collide with each other, bouncing off of each other. In effect, they spread apart. All right, and that's what we're trying to show here. They are spreading out. There's more space between the particles, and as a result, we say it is less dense. If you take a look at this, if we were to draw a box, we should show here there's only 2 particles in this amount of space compared to over here, where you've got a whole bunch of particles, and we say that this is more dense because there's many more particles in the same given space. Remember, when things are less dense, they have a tendency to be lighter. They tend to be buoyant. They float, right? So in this case, the warm air is going to rise. And what happens to cooler air? Well, because they have less thermal energy, they are attracted to each other. So you get more particles in a space we say that that is more dense, we say that is heavier, and so the cold air or the cold water or the cold magma, if we're talking deep in Earth's interior, sinks, right? Because they become heavier. All right, the third kind is radiation. Radiation does not require a medium to travel through. It can travel through a vacuum. Think sunshine, right? You get a sunburn. That was a result of electromagnetic waves. There are different types of electromagnetic waves. They tend to the ones that really transfer a lot of the heat energy tend to be your higher energy waves, ultraviolet, infrared, gamma, microwaves. And again, this is how the sun delivers thermal energy to Earth, right? Electromagnetic waves traveling through a vacuum. That vacuum is outer space. There's no air out there. That's what we mean by saying a vacuum. So the final things here, just remember that heat travels from areas of high temperature to low temperatures. And once you reach thermal equilibrium, right, that is where all the temperatures are equal, the temperatures are uniform throughout the material, then heat flow stops. Okay, and this brings us up to the last thing we want to talk about, and that is insulators. Insulators are things that are bad conductors. We use insulators. If you're touching a hot electric cord, you would like to have a plastic insulation wrapped around your electric cord so you don't get shocked, right? If you're touching something, you're cooking something on the stove and it's hot, you don't want your hands touching the hot metal. You would like to have some rubber or plastic handles on your kitchen utensils. So insulators are things that are poor conductors. The reason why is they have large air spaces between the particles. So just like with convection, they slow the transfer of energy, right? The more space you have between your particles, the slower the transfer of energy is. Well, I hope that was helpful. Go ahead and write yourself a little bit of a summary of what you learned, and we'll talk to you soon.